How's it going, guys? Welcome to the second Eagle 7.0 tutorial on which we're going to build the final circuit for our project. And as you can see, I've already created a blank schematic in order to do so, so let's jump right in and start adding some parts. So the first component of the circuit is going to be an LM7805 voltage regulator. So I'm going to scroll down all the way to the bottom and grab the 78XXS component, click on OK, place. I'm also going to need two filter capacitors at the input and output of the voltage regulator, so I'm going to go into RCL, click on CUS, and place the two caps on each side. Press on escape and cancel. I'm also going to need some kind of a way to connect to the PCB itself, so I'm gonna add a connector. So I'm gonna go into con jack and drop a 0202 jack, press on OK, put it right there. I would also like to create some kind of a reverse polarity limiting feature, so I'm gonna add a diode in series with the input, so I'm not worried too much with the voltage drop across the diode. I'm just gonna put it like so. And there we go. I would also like to have some kind of an indicator that the circuit is in reverse polarity, so I'm gonna go into LED and scroll all the way down. There's an LED section, 5mm LED, press OK. So remember, this is going to be in reverse, so we want it upside down. Press escape, and at the same time I'm going to go ahead and add a current limiting resistor for that same LED. So RCL, close tab, RUS, put this resistance to the LED. There we go. Press escape and cancel. I would also like to have an LED out the output of the voltage regulator in order to know that the circuit is functioning okay. So what I'm going to do is right click and copy the LED. I'm going to rotate it in the opposite direction. Right click the R1, copy, and paste it out the output. So obviously this LED will light up when the circuit is in reverse polarity, because the current is going to be going from pin 3 back into pin 1, and this one is going to light up when you have the voltage that you want at the output of the voltage regulator. I'm going to also need some kind of a way to connect from the output of the voltage regulator onto a breadboard or any other circuit, so I'm going to go into place component, pinhead, and I'm going to add a 1x2 header. So this one seems good. Press OK and add that at the end of the circuit. Cancel. And what I'm going to do now is zoom in so I can rearrange my circuit a bit better. So as you can see, I've used the option of zoom select, and you can essentially put a rectangle around your circuit and it's going to automatically pan your view to the selection. Alright, so now that we have the general layout of the circuit, I can go ahead and select the wiring tool and start connecting my barrel jack to the polarity reverse diode. So as you can see, while in this mode, I can drag and drop the wire. I can also right click to go into different modes. So if you want to have some kind of a fancy wiring mesh, or you need to avoid obstacles, you can do so. I would not recommend using the other options unless you really have to. Always go with the straight lines. So first and foremost, I'm going to left click at the diode, and as you can see now, I'm still able to make a second connection from this mesh. If I want to leave this menu, I can press on escape and then connect a different mesh, but in this case I actually do want to connect this first LED like so. And then I'm going to press escape since I've completed this particular mesh. Something you want to keep in mind is that if you have two wires crossing like so, Eagle is not going to automatically assume that this is a junction for all of these wires. So what you need to do is use the net junction tool and position that right in the intersection. So in my case, where I have the LED, the diode, and the jack, I would like to put it like so. Give it a specific name, and then that's going to tell Eagle that yes, this connection goes to the 3 of these elements. And let me just quickly delete that. And this concludes our tutorial number 2 for today. We're going to finalize the circuit in the next tutorial and start moving on to creating the PCB layout, so stay tuned.